We proceed in pseudo calculus problems. Pseudo calculus problems in which we have started the discussion, and it is problem centric rather than concept centric. So pseudo calculus, pseudo multivariate calculus was the last series which was more or less fundamental centric, that what is pseudo. Now the idea is, can we take over the example by example? So that is the concept, and in example by example, we are covering extensively calculating the surface area of a circle. If I have a circle, then what is the surface area of a circle? And in that phase, we are trying to calculate surface area of a circle through a spherical coordinate system. So when we talk about a spherical coordinate system, then what can be the surface area of a circle? Anyway, now when we talk about a spherical coordinate system, then there are two ways in a spherical coordinate system. I'm sorry, there are three ways into a spherical coordinate system. One way is pure spherical coordinate system in Cartesian coordinate system. The I'm really sorry. So if I'm trying to calculate the surface area of a circle through a spherical coordinate system, there are two ways in a spherical coordinate system. Two ways. One spherical coordinate system is a hybrid model that comes from Cartesian coordinate system. Hybrid model that comes from Cartesian coordinate system, and that hybrid model is x equal to r sine theta, x equal to r sine phi cos theta, y equal to r sine phi sine theta, and z equal to r cos phi. This is hybrid Cartesian coordinate system and a spherical coordinate system. Hybrid model it is called. Why it is hybrid model? Because it has, why it is hybrid model? When I say that what is your position vector of any point on a sphere in a spherical coordinate system, someone would reply immediately r sine phi cos theta I plus r sine phi sine theta j plus r cos phi k. It has both. It has a spherical coordinate system and Cartesian coordinate system. It has a spherical coordinate system because there is a phi, there is a theta, and there is r. It is Cartesian coordinate system because there is I, j, and k. This is hybrid Cartesian spherical coordinate system. Whereas if I talk about the only spherical coordinate system, then it will come as r, r unit vector plus r sine phi theta, theta unit vector plus r phi unit vector. This looks little awkward, but this is the pure spherical coordinate system. I'll take a sphere. Okay, so okay, consider this is a sphere. Doesn't look like a sphere, but consider this is a sphere. And this sphere is centered at the origin. This sphere is centered at the origin, means this is the xy plane, and it will go and cut the sphere at the middle. Top of the sphere is top hemisphere, and bottom of the sphere is bottom hemisphere, and it is cut by xy plane. Okay, if cut by xy plane, the center of this sphere is origin. Consider any point P here, any point P on the sphere. If I have any point P on the sphere, then what is the coordinate of this point P? Okay, then if I see the hybrid model of a spherical coordinate system, then there is angle theta and it goes in xy plane. There is radius r that moves all along. It goes in vertical plane, it goes in horizontal plane, and it goes everywhere r is there. And there is angle phi which makes from vertical. If we see the vertical, then phi angle makes from the vertical and radius is sliding like this from 0 to pi. Then there is an angle theta that goes in xy plane and 0 to 2 pi, and radius that starts at origin 0 and it expands in radius way. There are three orthogonal components. If I talk about any point on this sphere, any point on this sphere, then from center if I draw a line, that is radius. Okay, what is position of this P? If I talk in hybrid model of a spherical and Cartesian coordinate system, then P is R sine phi. If I take any R and vertical angle is phi, R sine phi falls on xy plane. If there is any R, if there is any R and it makes angle phi with the vertical, R sine phi falls on xy plane. R sine phi cos theta I vector, R sine phi sine theta j vector, R cos phi k vector. It has I, j, k, r, phi and theta. This is the hybrid model of Cartesian and spherical coordinate system. Thank you very much. What is the pure spherical coordinate system? If I talk about pure spherical system and the point here, okay, pure point P, if I talk, then one is radius that is r, and another two in spherical coordinate system is theta and phi angle, phi with the vertical and theta in horizontal plane. Okay, so that point will be r theta comma phi, but theta and phi being angle, I have to denote it as a length. Then theta, if it goes, it makes an arc, that is, if this is r sine phi theta, that is the arc. If this is arc, then r phi is the arc. So the point P is r comma r theta, sorry, r sine phi theta comma r phi. Position vector is r unit vector plus theta unit vector. I'm sorry, r sine phi theta unit vector plus r phi unit vector. So in pure Cartesian, in Cartesian spherical hybrid model, position vector of any point P from the center is r sine phi cos theta I plus r sine phi sine theta j plus r cos phi k. Whereas position vector in pure spherical coordinate system is r unit vector plus r sine phi theta unit vector plus r phi unit vector. Okay, now we are trying to calculate the area of a circle in xy plane. If xy plane cuts the sphere, there is a circle out there. What is area of the circle? Radius of the circle, if I say, the radius of the circle, if I say, then it is r only. That is the radius of the sphere. But when we calculate, we radius take any point in the sphere, then r sine phi is not the r. There are two things. If I take a sphere and origin of the sphere, center of the sphere, if I draw any radius and it's passing point P, any radius when it is passing point P, then that is the radius of the sphere. If I take, and this is the vertical line and this is the radius, it makes phi angle. If I take r sine phi, it falls on xy plane. Whatever falls on xy plane, that is not the radius, it is less than radius. If I take the circle on the x, if I make a cut on the xy plane, it will form a circle on the xy plane. The radius is r or a, that is the radius of the sphere. But if I take any moment, if I take radius as r or a or r sine phi will fall on xy plane, that will be lesser to the radius of the circle on xy plane. Anyway, now question is, there are two questions now. Okay, first question is, what is the area of a circle when I cut the xy plane, where I know the radius is a. Consider the sphere has a radius small a. When I cut this sphere at the xy plane, then at that time there is a circle and radius is a, that is the radius of the sphere. But I am free to cut at any height. If I cut at any height, at that moment radius is r, that is variable. What is the area of that circle? Again, pi r square, where r is the radius at that moment. Where if I cut at xy plane, then what is the area of circle? Pi a square, because a is the radius of the sphere. If I cut this sphere at any height, considering at that point radius is r, that is variable, then at that moment radius of the circle is pi r square. Can someone calculate the radius of the circle at xy plane or anywhere? Both. This is what we want. Now, if I'm talking about xy plane radius, there are two ways of calculating the radius that we have seen in the past video. If I take position vector p here, then dp by d theta. If I take the xy plane, a circle, in that circle if I take and trying to calculate area, okay, if I have a if I have a circle in xy plane, if I have a circle in xy plane, this is the where I cut the sphere in xy plane. This is the area I'm trying to calculate, where radius is a. Radius is starting from origin and it is going till a, because we are trying to calculate the area. And theta angle makes 2 pi degree, whereas phi is 90 degree constant. Okay, let's not take phi as 90 degree, phi as phi. If I take phi as phi, then I can calculate the, if I make cut at xy plane, then I can calculate the area at xy plane. But if I cut at any plane, then their radius is r. Then this circle will be in equation of phi, because phi is the angle it makes from the vertical. This is phi. Phi will go to a location where phi will be constant. In this constant, here if I make a cut in the sphere, it will make a circle which has radius r. r square, r square plus this is the a square, that is radius of the sphere. A square equal to r square into z square, that is the height. Okay. Or if I move this phi and make 90 degree, then this will be complete a, radius of the sphere, and this area will be pi a square. But I want the area in term of sine phi, so that any moment I can, whatever the phi is, if phi is 0, then there is no circle here, there is no area. If phi is moving, I want I want area of a circle in function of phi. That is the concept. Anyway, what is the area of a circle if I talk in a spherical coordinate system? We have seen it. It is, what is variable here? R is variable and theta is variable. R is variable because R will go from 0. Everywhere it is flat. If I am trying to calculate the circle, everywhere it is flat. XY plane, then flat circle. If I go little up, then flat circle. Flat circle means phi will be constant at that moment. So if phi is constant and it is area, then two entity will be variable. That is for sure. What are the variable here? Theta and r are variable. What we have seen, the area vector in a spherical coordinate system, if I have a position vector of any point P, if I have a position vector any time P, any point P, position vector, dp by d theta, that is one variable, cross dp by dr, another variable. R is one variable, theta is one variable. dp by d theta cross dp by dr into d theta dr is the area vector. If I take position vector into pure position vector, position vector into pure spherical coordinate system, position vector into pure spherical coordinate system, then it will probably, okay, we can try. If I take the position vector in pure spherical coordinate system, it will give area vector, but this is not the perfect way of calculating the area, but we will try. dp by d theta cross dp by dr, because theta and r are variable, cross product d theta dr. Why I am saying it is not the perfect way? When we are taking pure spherical coordinate system, then there should be one independent variable, not two. If I'm trying to calculate area, then there will be one independent component. If position vector is in pure spherical coordinate system, theta r and phi unit vector. In that sense, d theta dr will not give the correct area vector. Okay, correct. It is area vector, but it will not give the correct area. Then we have to go with the volume concept. Then we will have two independent component in differential area of the calculus d theta dr. If I want d theta dr and everything similar way in Cartesian coordinate system. If I say dx dy, then it is calculation of a volume, not area. Okay, if I just say dx, then it is calculation of area. If everything is in Cartesian coordinate system, if everything is in Cartesian coordinate system, dx dy is calculation of the volume, not the area. Anyway, if I say dp by d theta cross dp by dr, dp by d theta cross dp by dr into d theta dr, typically it gives the area vector in Cartesian spherical coordinate system hybrid model. That is for sure. Where P is r sine phi cos theta I plus r sine phi sin theta j plus r cos phi k. If this is P, where it is a spherical and Cartesian hybrid model, then dp by d theta cross dp by dr will into d theta dr will give the area vector in the theta r plane. If I say dp by d theta cross dp by d phi d theta d phi, then it will give the area vector in theta and phi where r is constant. Okay, I believe it makes sense. Where r is constant. Okay, that is the d theta. D okay. If I'm trying pure spherical coordinate system, then I can go with the kind of different whatever it is. Just proceed. Okay, the concept is that I have to find area vector. If I find area vector, calculating the magnitude of the area vector will give the area. Now if I'm trying, I have two surfaces here. If I talk about 2D surface, then this is also a 2D surface where radius is constant. If I take xy plane, if I cut it in xy plane, and there is again a surface, their phi is constant. Their r and theta are variable. Okay. Whereas if I take the surface, then here r is constant, theta and phi are variable. Okay, if I take any position vector P here, there are many concepts that comes in area vector. We have talked about all the concepts in the pseudo multivariable calculus. This is pseudo calculus problem, pseudo multivariable calculus. We have talked about all the possible concepts in the area vector. Now, in the area vector, when we are taking the area vector and it is a hybrid model of x, y, j, then we generally go with the if I say theta r, then there is a coordinate system. I take theta r. Then there is a coordinate system called x and y, and on top of x and y, we have a position vector called p. I believe it makes sense. If I take a sphere and xy plane cuts at the center, then this is xy plane where x and y are independent to each other. Okay, in that fashion, I have xy plane. On top of xy plane, I have a point here called P, that is xyz. Now this is xy plane, and this is xy plane, this is xy plane. And then this side I take, this is theta, xy plane is represented as theta and r. I take another plane as theta and r. Theta and r plane, x and y plane. On top of xy plane, we have position vector P xyz. Okay, here if I take three points here, theta comma r 1 point, theta plus delta theta comma r 1 point, theta comma r plus delta r, theta comma r, theta plus delta theta comma r, theta comma r plus delta r. Similarly, I have 3 points here. Okay, if I consider xy plane and theta r plane, they are mapped to each other where x equal to r sine phi cos theta, y equal to r sine phi sine theta function. Then similarly, the corresponding point here in xy plane, here is point P. P is x comma y, that is gr comma theta comma phi, hr comma theta comma phi. If I take phi constant, then r g theta comma r s theta comma r. Like like here, there will be second point, that is this is P, this is P1. P1 is g theta plus delta theta comma r h theta plus delta theta comma r. I'm sorry. Yes, and there is point P2. G theta comma r plus delta r s theta comma r plus delta r. Okay, now corresponding to these 3 points, if I go up, then on the sphere, I will have 3 points here. One point is P, that is x comma y comma z, another point P1, another point P2. What is the surface area what we see? If I make a delta r change here, delta r change that we are taking, with that delta r change, I'll see a change here, delta x delta y. Because of this change up, I'll see a change in the position vector here. Now, if I take any point P here, I can write as P. Okay, if this is point P, then this is the position vector of P. From the center, if I draw, P corresponds to a position vector of a surface area. If I have a position vector and if I calculate derivative of it, it will give the surface area vector. D of P is the surface area vector. In that sense, D of P equal to D of P by D theta R into D theta R. Means I can write d of p is same as d of p by d theta r into d theta r. X equal to x into y by y. Same thing. Now d of p by d theta r means if there is 1 unit of area change in theta r plane, how many unit of area change I see in p, that is dp by d theta r, they got clinched to each other. They stick to each other. In that way, if there is a delta theta delta r change there, then it brings how much change here? That is P1P cross P2P. Okay, P1P cross P2P by delta theta delta r into delta theta delta r. That is same as dP by d theta r into d theta r. P1P cross P2P by delta theta delta r. Please watch our previous video. If someone settle it down, it becomes dP by d theta cross dP by dr into d theta dr. This is typically called area vector. But since it is theta and r we have taken, this area vector will come on the surface area in xy plane. If I had taken theta and phi, then this was the area vector. What variable we are taking? Theta and r variable where phi is constant, then it will come in any horizontal plane where phi, this is angle phi. Phi is 0 means here. Phi is some angle, then it will cut here, theta r. If phi is 90 degree, then it will cut on xy plane theta r. If theta r are variable and phi is constant, then area vector will be dp by d theta cross dp by dr. If 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 theta is constant and r and phi are variable, then area vector will be dp by dr cross dp by d phi dr d phi. I believe this is little cumbersome, but this is $1 trillion explanation, $1 trillion kind of concept behind the area vector in a spherical coordinate system. We are interested in d, theta and r. Let's start with the spherical coordinate system. Now position vector P in a spherical coordinate system. Now we are trying dP by d theta. dP by d theta. If I say dP by d theta, okay, typically it comes in phi theta plane. Okay, what is phi theta plane and what is phi r plane? This is one explanation of the area vector. Another explanation of area vector is if I take any point P here, and make a cut in theta r plane and make a cut in theta phi plane. I'm sorry. If I take any point P here, I make a cut in phi theta plane. I make a cut in phi r plane. If I make a cut in phi theta plane, it will come as an arc. If I make a cut here, then it will bring an arc. If at point P I make a cut in phi theta plane. And if I make cut in phi r plane, then in phi theta plane, there will be an arc. There will be an arc like this, like a circle, where point P is here. That is theta, phi theta plane. Similarly, phi r plane, there will be another point P here. Now, if I get the vector representation of theta phi plane r at point P and vector representation of theta phi r, phi theta plane curve and phi r plane curve, if I get vector representation of these two curves, if I do cross product, then I'll get area vector at point P. Okay, but I have taken theta and r as variable, phi is constant, mind it anyway. Now, what is the curve vector in phi theta plane? The position vector point P is r unit vector plus r sine phi theta unit vector. Okay, means r sine phi theta unit vector, because any point P is r comma theta comma phi. R is length, theta and phi has to be in length. Theta length is the arc along the xy plane when theta is sweeping. That is r sine phi theta. Phi arc length will be r phi. That's why the position vector in pure spherical coordinate system is r unit vector plus r sine phi theta, theta unit vector plus r phi unit vector. If I try to get this unit vector, the length vector means if this is a straight line, if this is a straight line, if this is a, if this is a straight line, then what is the length vector of this straight line? That if this is point P and this is origin, then this is the position vector is the length vector also. But if it is a curve vector, curve line, and this is point P, then what is the length vector? This position vector will not be the length vector if this is origin and this is point P. Length vector will be tangential vector along the line. So for get the length vector, we take out one independent variable from the position vector and we get the length vector. This is what we have seen in the multivariable, pseudo multivariable calculus. In that sense, our position vector is r unit vector. So if I am trying to calculate the surface area vector at any point P, I make a cut in the sphere at point P on the sphere in phi theta plane and phi r plane. In phi theta plane, if I make a cut, r is constant. In phi r plane, if I make cut, then theta is constant. In that sense, in phi r plane, what is the position vector of the curved line? The position vector of a straight line is r unit vector, r sine phi theta, theta unit vector, r phi unit vector. From here, if I have made a cut in phi theta plane, I'll take out theta. Then it becomes r by theta, r unit vector plus r sine phi theta by theta, theta unit vector plus r phi by theta, phi unit vector. In that sense, since I have taken out theta, then it multiplied by theta. This is theta phi line vector, cross product with the another unit vector where r I have to take it out. Another unit vector is r unit vector, r sine phi theta, theta unit vector plus r phi unit vector. If I take out r from there, then it becomes r by r unit vector, r sine phi theta by r, theta unit vector plus r phi by r, phi unit vector into r. Division, I will change it to differentiation. Mind it, this is going to hit the surface. Division, I have to change it to differentiation and multiplication into integration. Then the surface area vector at any point P where theta and r are variable, one will become dr by d theta r unit vector plus r sine phi theta unit vector, theta by theta gone, plus r d phi by d theta, phi unit vector. Bracket close into theta into d theta, cross product. Now here I have to take out r. dr by dr, r unit vector plus r sine phi d theta by dr, theta unit vector plus dr d phi by dr, phi unit vector dr. Okay, this if I settle it down, it becomes dr by d theta, r unit vector plus r sine phi d theta by d theta, theta unit vector plus d phi by d theta phi unit vector bracket close cross product with dr by dr r unit vector plus r sine phi d theta by dr theta unit vector plus r d phi by dr phi unit vector bracket close d theta dr. This is exactly dr by d theta cross d, I'm sorry, dp by d theta cross dp by dr. dp by d theta cross dp by dr into d theta dr. This is area vector. Where in first, this is not mentioned in the book. dp by d theta, here r is constant. This is not mentioned in any of the book. dp by dr, theta is constant. Okay, d theta dr. If I settle down the first one, dp by d theta, dr by d theta, r is constant, it will become 0. Another is r sine phi theta unit vector d phi by d theta. Phi we have taken a constant when we are trying to calculate the surface area at a particular phi. D phi by dr, d phi by d theta is 0. Cross product dr by dr, r unit vector, r unit vector. R sine phi d theta by dr, here theta is constant 0. D phi by dr, phi is constant 0. It becomes now r sine phi theta unit vector cross r unit vector. It becomes r sine phi unit vector, r sine phi unit vector. Okay, I'm sorry, r sine phi unit vector. Okay, d theta dr. Now this is a phi. What is phi unit vector? What is the area vector? Is it complete? Is it complete area vector? No, because the area vector direction what we are getting is phi unit vector. We don't want phi unit vector as area vector direction. Okay, what is the lagging here? If this is a sphere, if this is a sphere, then from center, if I take any point P, then that is the radius vector. That is for sure. If from the center, this is the origin of the sphere, and if I draw phi, then what is the phi vector? Phi vector is the arc vector. That is phi vector. This is not the phi vector. This is the r vector, radius vector. This arc is phi vector. On xy plane, if I move in theta, this arc is theta vector. So if I am getting our area vector is r sine phi unit vector, because it is r sine phi theta unit vector cross r unit vector, r sine phi unit vector. But we want the area vector because we have taken area vector in theta r. So area vector will be perpendicular to it. If that is the case, and any moment we have a phi vector, phi means this is the vertical circle, then this is phi vector. Phi vector, if I want as a vertical vector, then whatever phi angle we are making and whatever phi is, it will be sine phi. So it become r sine phi into sine phi, and now new vector will come, that will be the area vector. Right now we have r sine phi unit vector. If I want exact vertical vector, then it will be r sine phi into sine phi, then vertical. This is the area vector in the r theta plane. Now it becomes r sine square phi, r sine square phi dr d theta. This is the area vector for the any phi angle. Okay, if I am making, if I, this is the xy plane, if I am making cut little above, and here, if I make a cut here where the angle is phi, so I'll rephrase it. If this is centered at the origin, from the origin, this is the angle, this is the vertical. This is making angle phi. At any angle phi, we make a cut here. What is the surface area here? If phi is 90 degree, then if I make a cut, this is xy plane where radius is a, that is the radius of a sphere. If at any angle phi, if I make a cut, then what is the surface area here? Surface area vector is r sine square phi dr d theta, dr d theta, where phi I have to assess whatever it is. Now it is sine phi, I can keep outside, r dr, r square by 2, d theta, theta 2 pi. Pi r square sine square phi is the area of a circle in a spherical coordinate system. When phi is 90 degree, it is pi a square. radius is 0 to a. I'm sorry, I'll start rephrase it. Area vector is this is not available in any of the book. R sine square phi dr d theta is area vector. Now sine square phi I can keep outside r dr r square by 2. Now radius is 0 to a. A is the radius of the sphere. 0 to a, then it will become a square by 2. Okay, then it becomes sine square phi a square by 2 d theta theta 0 to 2 pi 2 pi 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 a square sine square phi is the net area. Pi a square sine square phi is the net area. When is when phi is 90 degree, then it is pi a square. That is the area of a circle at xy plane. Okay, what about when phi is 30 degree from the vertical? Then whatever sine 30 degree is, pi a square sine 30 degree whatever comes square. That is the area at any point. Mind blowing, amazing. When pi is 0 at top, then it does not make any area at all. Then it is 0. If phi is 45 degree, that I know. Sine 45 is 1 by square root of 2. Then it becomes pi a square by square of 2 whole square. Pi a square by 2 of the area of a circle when it is making 45 degree. Someone can try. We will try to prove it through Cartesian, which is long time happened. Cartesian and polar coordinate system, Cartesian and spherical hybrid model also. Now question is arising, what is the surface area? What is the surface area of a circle in a spherical coordinate system where circle correspond to xy plane, that is the circle, or at any height h, if I make a cut, then what is the circle there? Instead of saying any height h, I will say any angle phi. If I make a cut, then what is the circle area at there? Okay, people can try other method also. Means if this is the vertical and this is phi angle, then this radius will be a sine phi. Then pi r square is the area there. Then it will become pi r square sine square phi. This is what we have said. I'm sorry, pi a square sine square phi. This is much easier. If I say what is the area here, not in the middle of the sphere, somewhere here where angle is phi, if this is the radius a and makes angle phi, then a sine phi is the radius. Then area will be pi r square, that is radius here, that is pi a square sine square phi. This is what we have said, pi a square sine square phi. We will prove this through the Cartesian and spherical coordinates. Mind-blowing concept of calculating the surface area of a circle, where circle in the on a sphere, it is at any height. Someone can try it for parabola surface also. If there is a paraboloid, then anywhere if I make a cut, then what will be the circle area? Mind-blowing, amazing. Please do not mind supporting us. +91 is the India country code. 9483160610 is the telephone number. +91 is the India country code. 9483160610 is the telephone.